Hi, I'm Mary Grace De La Cruz. Have a good day or night to you, ma'am, and my fellow classmates who are watching my report. My report is all about rubber production or Hevea brasiliensis. History and origin of rubber trees or Hevea brasiliensis are native to the Amazon rainforest and South America. The indigenous peoples of the Amazon used latex from the tree to make waterproof items. In the late 19th century, rubber became a valuable commodity, leading to its large-scale plantation in Southeast Asia, including the Philippines, Malaysia, Thailand, and Indonesia. The British and the Dutch played key roles in introducing rubber cultivation to their colonies. Native siya sa Amazon ug gigamit na sa katong mga katutubo para sa mga waterproof nga gamit. Then in the 19th century, kanang diha na dayon nga mas importante na ang goma ug gitanom na siya sa timog silangang Asia. Then apil na dira ang Pilipinas. Sa tabang pod sa mga British ug sa Dutch diha na introduce ang goma. Botanical description of rubber tree Hevea brasiliensis belongs to the Euparbiaceae family and thrives in warm, humid tropical regions. It has a tall, straight trunk with smooth grayish bark containing latex vessels. The leaves are trifoliate and the tree produces small, pale yellow flowers and three-lobed, woody fruits that release large oval seeds. Requirements of rubber Hevea brasiliensis requires specific soil condition for optimal growth and latex production. The key soil requirements include well-drained soil. Rubber trees do not tolerate waterlogging. Deep, well-drained soil with good aeration are essential, typically loamy or sandy loam soils. The soil should be deep at least 1.5 to 2 meters to support strong root development. Climatic requirements. Rubber trees thrive in tropical climates with 25 to 35 degrees Celsius temperature, 2,000 to 2,500 mm annual rainfall, and high humidity above 75%. They require 5 to 6 hours of sunlight daily, grow best below 400 altitude, and need protection from strong winds. Cultural practices for rubber production. Site selection. Choose deep, well-drained soil with adequate rainfall. Avoid flood-prone areas. Land preparation. Clear weeds and unwanted vegetation. Plow and harrow for soil aeration. Seed bed preparation. Use well-drained organic-rich soil and ensure proper seedling spacing. Then planting and transplanting. Planting rubber is propagated using seeds or bud stump. The process involves direct seeding. Seeds are sown in a nursery where they germinate and grow into seedlings. Bud stump. Selected seedlings undergo budding, grafting to improve yield and disease resistance. Thinning and replanting. Thinning done 3 to 5 years after planting to remove weak or overcrowded trees, improving growth and latex yield. Then replanting occurs after 25 to 30 years when trees become unproductive. Old trees are cleared, soil is enriched, and new seedling or bud stump are planted. Healing up. The healing up of rubber production typically refers to the practice of mounting soil around the base of rubber trees. This agricultural technique is used in rubber plantation to improve tree stability, prevent root exposure, and enhance soil moisture retention. It is particularly beneficial in areas prone to soil erosion, waterlogging, or poor soil structure. Off-barring in rubber production. Off-barring is an essential soil management practice in rubber plantations that involves removing soil from around the base of rubber trees. This process is typically carried out before fertilizer application to improve nutrient absorption and overall tree health. Weed management in rubber production. involves several methods to control weed growth and ensure healthy tree development. Then manual and mechanical control. Hand weeding and slashing are common but labor intensive. Then ang chemical control, herbicides, example ang glyphosate, paraquat, help manage weeds efficiently. Cultural methods, cover crops, example legumes, suppress weeds and improve soil quality. Integrated weed management or IWM combines manual, chemical, and cultural methods for sustainable control. And water management. In rubber production involves irrigation, drip or sprinkle for dry season, then drainage system, then to prevent waterlogging, soil moisture conservation, using mulching and cover crops, rainwater harvesting for dry periods and climate adaptation strategies like deep planting and contouring. These practices ensure healthy growth and sustainable latex production. Fertilization. Fertilization in rubber production involves applying nitrogen, phosphorus, potassium, and micronutrients to support growth and latex yield. It follows different strategies like nursery or NPK for seedlings, immature high phosphorus for roots, and mature high potassium for latex. Methods include broadcasting, ring application, and foliar spraying with organic option like compost, improving soil health. Insect pest management of rubber. Mealybugs sucks up, weakening trees and reducing latex production. Then control measures, regularly spec and remove infested plant parts. Maintain field sanitation by removing weeds and plant debris. Then termites attack roots and stems, causing tree death. Then field sanitation, remove deadwood, decaying plant matter, and tree stump which attract termites. Then termiticides, apply soil treatments with chlorpyrifos or fipronil to create a barrier against disease and management of rubber. Disease name, leaf blight and powdery mildew. Causal organism, Corynespora cassicola. Damage of the rubber, brown spot on leaves, defoliation, reduced latex yield. Then control measure, use resistant clones, apply fungicides, example carbendazim, mancozeb, and improve field sanitation. Then powdery mildew or a causal organism, Oidium hevea. Then damage of the crop, white powdery mildew, fungal growth on leaves, reduce photosynthesis. Then control measures, spray sulfur-based fungicides or neem oil, prone infected leaves. Harvesting. Rubber harvesting involves tapping mature trees 5 to 7 years old by making controlled cuts to extract latex. Common methods include half spiral and quarter spiral tapping, using a tapping knife and collection cup. Latex is collected, coagulated, and processed into rubber sheets or black rubber. Sustainable tapping practices, including rest periods and stimulation techniques, help maintain tree health and maximize yield. Post-harvest handling operations of rubber includes latex collection, coagulation using acids, then rolling and milling to remove water, washing to eliminate impurities, drying and smoking to preserve quality, grading and packaging based on quality, and storage and transport in dry, ventilated condition. This tip ensure high-quality rubber for industrial use. Nutrient content. Rubber, particularly natural rubber, Hevea brasiliensis, consists mainly of CIS-14 polyesporin, a polymer that makes up about 94% of its dry weight. However, It also contains minor amounts of nutrients and other compounds. Proteins contribute to rubber elasticity. Lipids and sterols aid in elasticity and processing. Resins and tannins affect rubber properties. Carbohydrates present in the latex mainly as sugars. Economic benefits, environmental benefits leading to better health, job creation and income generation, provides employment for millions, especially in tropical countries, improving access to healthcare and nutrition. Poverty reduction. Stable income from rubber farming helps rural communities afford better living conditions and healthcare. Carbon sequestration. Rubber plantations absorb carbon dioxide, improving air quality and reducing climate change impacts. Erosion control. Tree roots help prevent soil erosion, reducing dust and airborne particles that can cause respiratory diseases. Microclimate improvement. Rubber forests increase humidity and reduce extreme heat, which benefits local communities. Industrial products made from rubber. Automotive and transportation. Tires used in vehicles, airplanes, and bicycles. Engine belts and hose. Power transmission and fluid transport. Seals and gaskets prevent leaks in engines and machinery. Shock absorbers and mounts reduce vibration and noise in vehicles. Electrical and industrial equipment. Electrical insulation, coatings from wires, cables, and circuit protection. Rubber rollers used in manufacturing, printing, and packaging. Industrial gloves and protective gear, safety in hazardous environments. Top producing region in the Philippines. The Bangsamoro Autonomous Region in Muslim Mindanao or BARMM is currently the top rubber producing region in the Philippines, contributing 38.3% of the national output in 2023. Then Zamboanga Peninsula Region 9 follows closely, historically leading production, while Soxargin also plays a significant role. North Cotabato, a province in Soxargin, is a major contributor with over 62,000 hectares of rubber plantation. Mindanao remains the center of the country's product of rubber. Varieties of rubber. RRIM Series Malaysia. RRIM 600 popular high latex yield, moderate disease resistance. RRIM 928 and RRIM 2020 improved gluons with better disease resistance. PB Series Malaysia PB 260 high yield, fast growth but susceptible to wind damage. PB 350 resistant to leaf disease, good for diverse climates.